Good morning, Jan.
Michael, good afternoon. How are you?
Doing very well.
Nice
Double
to hear that.
checking levels. Yeah, everything's looking good.
Good. I think I need your help here.
Uh-oh.
Yesterday I was looking into the this SQLite code again.
Mm-hmm.
Yeah, only yesterday morning I started on it. Um, and at once that problem from last time was gone.
Mm.
No idea why. Um, Nothing changed. The
Mm.
only thing were perhaps some Windows updates, a Visual Studio update, but the problem is gone. So I tried. I cannot get the problem again. So I think, okay,
Yeah.
that's bad good news, but let's be happy about it.
Yeah.
So I started cleaning up the code a little bit, and then while cleaning up, I also cleaned up one of the old tests, which I made afterwards to have a lot of reads at the same time, not
Mm-hmm.
just the write and the read, but really like 20 or 50 reads at the same time.
Mm-hmm.
And that one still fails, but in a very strange way. Now, just now I got back to C. I made a looping there, so until 60 threads all reading at the same time, not a problem. If I go to 70 threads, then the program, without any error message, that C program stops. Is that because I have too many threads? Am I doing something wrong? C is not
Yeah.
my my comfort zone. It's on a virtual machine with not too much memory for that virtual machine. So, but
Maybe,
until
yeah.
60,
Yeah, I mean, 70 doesn't sound like a lot of threads, especially for a server process, um, but yeah, on a virtual machine that doesn't have very much memory, maybe it is unable to allocate stack space for each of those threads.
because if I look on internet, you should count around 2,000 threads as a limit.
Yeah.
60, 70 is far below that.
Mm-hmm.
But I have the impression that is not related to SQLite. Because until 60, until the program stops without doing anything, he's reading all the data, all the threads at the same time. So that means that the problem is still somewhere in C sharp. Now I will show you. Let me share that screen. Which one is it here? This one. Yeah. Is that read?
Yes, it is.
And they start calling me, but that's not urgent. So this is the test. I renamed it to massive concurrent reads.
Mm-hmm.
What is it doing? It starts with the message starting with the time. Then it will set the database path. It will delete the database and it will create a new one. So
Mm-hmm.
once we make that connection factory, it will automatically create a new database, empty for the moment. And then just to be sure, I wait for 2 seconds. All this should be synchronous.
Mm-hmm.
I wait for 2 seconds, but that shouldn't make any difference. And then I have an array of tasks and I loop through them. I make tasks for max 2 number of tasks. Yeah, for the moment it's 10, but you can put it 100. a task will start an async transaction. And so everything that is inside here will be inside the transaction. Now, one thing I changed, I pass an ID parameter to that lambda function here, so that I can see which one has started. Because additionally, I got a lot of fun. I just took this I and I put it in here, and of course, then it's not going to work. Because by the time you reach here and you use I here instead of ID, then the value of I has been changed.
Yep.
So I passed it as a parameter, and now it seems to be working
Yep.
fine.
That's one of those things that Java got right and C# got wrong. Is that in order to capture a variable in Java, you have to declare it as final so that it can't change.
Yeah, but okay. I got bitten.
Yeah.
I found out why, and now I remember forever.
Yeah, it needs to be immutable.
Yeah,
Big fan.
immutability is a nice thing. So what I do in this lambda expression, I just do a select count and execute that. I wait for 2 seconds. I do another select count, and I output ended. Yeah, so started, ended, each time with that ID. Now, this parameter here, the true, that's what we want to have this backoff working. So if I put it false, then he's not going to retry. So now he's not going to retry. Let's see what it does. So 4.2 seconds, and you see it. It starts, all starting. Here the started, that is when he gets into the transaction. At that moment, the transaction is already active.
Right.
Yeah. On the started moment. Then ended. There the transaction is still active. Yeah, we are still in that lambda expression. And it continues like that. And the error I get here is, yeah, let me make that a little bit bigger.
Database is locked.
Yeah, database is locked, and that's very strange because I'm only reading. So it looks like something is not correct. And what's even more funny, if I put this retry to true, and I run it then, now it passes. Now it was only 10, but even if you do it with 100,
Yeah.
it passes, and you see that he doesn't restart often. Yeah, because that's the reason I added these values in it. So
Right.
at 0.7, he starts these transactions. Yeah, this one is just 1 second later. But then you see that, for example, the number 2 here,
Yep, that restarted.
he repeated.
Yep.
He restarted.
And then 0 was already there, and 9.
Yeah.
I don't think 9 had started yet. So that's 9 starting for the first time.
Yeah.
And then 5
So
restarts.
not too many of them are restarting. And if we make it a little bit funnier, we make it 100 now. Let's see what that does. And so because you have this thread sleep here in between, so these transactions really take a long time. So from these results, we can see that there is a lot of concurrency.
Yep.
But for one or the other reason, from time to time, it goes wrong. So now we have, well, it's not, oh, you put all of them here. Let's see, so starting, so from 0 to 99 got through starting. That's before the, that's here, right? Before the transaction starts here.
Okay.
And then
Yeah.
we get a few started. So they start at 25.
Oh, that's interesting.
39, 25.
Yeah, so
And
3 restarts before it even gets to 9. So that one failed early.
wait, 3 here. Yeah. But that's already 27. So we are 2 seconds later.
Okay, so it's it looks like SQLite might have a limited number of transactions, which kind of makes sense. You would expect a transaction takes resources, has to allocate something. So there's probably a semaphore in there. It's like, okay, once we have 9 or 10 active transactions, yeah, I guess it would be 9 is what we're seeing in this case. Then block until one of them completes. And then we saw 4 complete. So it says, all right, let's let 9 through. But in the meantime, 3 is also trying to do something. So there's probably some internal data structure that needs to lock in order to manage those transactions.
But that's in contradiction with what I see in C. In C, up to 60 transactions, read transactions concurrently. Yeah. One thing, the back off here, where is it? So I put the pauses, 2000 just for this test, another 2000, another 2000, and then I go for and each time he will just pause for this 2000. So it's normal that it goes up here in steps of 2 seconds. But so the first one starts at 39:25, and at 39:41, all of them are finished. So that's quite fast. Yeah. So the whole thing within 18 seconds. So there is a lot of concurrency.
Yeah.
But I'm wondering why.
And also the time inside of the Lambda is 2 seconds, if I remember correctly.
Yeah. Wait, if I go here, yeah, that's this sleep is 2 seconds.
So it could just be that because of those times being synchronized, something is finishing at the same time that first of all, all of the concurrent transactions are finishing at the same time, but then once one of them fails, its time delay is the same as the transactions that do successfully begin at that point. So it's going to try to start at the same time as other things are trying to finish. So I think we've got a 2-second pulse that's where you've got a lot of contention during those periods.
Mm-hmm.
So I think if you were to stagger or even randomize the delays, then it might have less contention and higher concurrency.
1800. Okay, with this retry, actually we solved the problem, but the fact that I don't understand what is going on is something which I don't like. Because that might give other trouble later.
Yeah.
Where a lot of magic will happen and we don't understand why. So here they are. So now we wait between the reads for 1.8 seconds. See, this one got started, so ended, and then,
Yeah.
for example, 9.
So it ran a batch of them, finished those, and then it started the next batch.
Yeah.
And I don't see any restarts there yet. I would have still expected restarts.
Yeah. Wait, 10, haven't we seen 10? No, we have not seen 10. Here, 9. We saw 9 somewhere. Yeah. Here.
Okay, so how much time is between the original 9 started and then the second 9 started?
Well, that's logical, huh? Because we have 57 here. So the first restart can only be at 59. It's 2 seconds to retry. So we can have restarts from here onwards.
Yeah.
Then number 16 is not a restart. 17 also not. 10, 9, 19, 11, 20. Yes.
Yeah, there's 9 restarting.
Yeah.
That's at 0, 0. So it it looks like that is the sum of the time that it was inside the lambda and the 2 seconds before it did the restart. So that's the 1.8 plus the 2.
Yeah, but why would it fail? That means that the first read goes through and the last read would fail. Because the transaction sets up here. Now in SQLite, a transaction will always start as a read transaction. And it will, the moment that you write, it will automatically go up to an exclusive lock. But we are not writing here at all. So we see very, very little restarts. Huh?
Yeah. So my guess there, so the rules that you're talking about there are kind of the general. This is the behavior that we want the application developer to see. But in order to get that behavior, there has to be some kind of mechanism happening inside, and that mechanism needs to enforce some other rules. One of those being the independence of transactions, and so it has to know which objects were read, so that when you read a second time, it's going to give you back the same objects. And so here you're doing a select count from fact type. So
Mm.
the only way that it can ensure that that's going to be the same count that the second time you execute it um, is to um, to keep some sort of a table level snapshot. Um, it might not even, yeah, I don't know about the internals, but it could just be table level snapshot. So I'm going to just snapshot the whole table, and then if somebody were to come along and insert, I would still select from that snapshot. Um, but that sounds oddly specific. That would just solve this one problem, and so they might go with a more general solution, which might actually include doing a table lock, even to do a read.
Um, Wait, the database is in wall mode. Yeah, this write ahead logging.
Uh-huh.
So that means the moment that you write something,
Mm.
is not changing the database, is adding it additionally to the database.
Mm-hmm.
Yeah, is making a new file. And so the moment that you go and read, he will go to the old database, the existing database. But imagine you do a first a write transaction.
Mm-hmm.
And then you start, and that one finishes. And in meanwhile, there are read transactions going on. Then he cannot combine the original database with the new
Mm.
write. And so the next write will be added to that extension. Yeah, so you have
Okay.
the original database written, 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 and it gets longer.
Yeah. Yeah.
And every time you start a read transaction, he will consider the original database plus the portion of that extension that existed at the moment that you start the read transaction. Yeah,
Right.
because
Okay. Yeah.
if you've
That
written
makes sense.
already something that was written before you start the read transaction, then this portion you need to consider.
Mm-hmm.
But the portion that will be written afterwards, or write transaction that is in progress, we don't have to consider it. So
Mm-hmm.
the only thing they have to do is not take a full snapshot, but just a pointer to the last successful write.
Yeah. And in this particular case, there are no writes happening, so um,
Yeah.
so everybody should have the same pointer.
So it's just a pointer.
Mm-hmm.
So there is no reason why there should be a limitation.
Yeah.
And the fact that in C it seems to work. So the difference between what I did in C and what we are doing here is here we are using tasks. So
Mm-hmm.
no separate threads probably.
True.
Not sure about that, because if I do here
Mm.
async,
Oh, right. Right. Yeah.
it's going to use task.run.
Yeah. That does start a thread. Yeah.
That does start a thread.
Yeah. And furthermore, I think I just saw when you scrolled up, your retry is doing a thread sleep, and that's because it's already inside of the synchronous code. It's already inside of the thread.
Wait, the retry here?
Yeah, right there. Yeah, it's doing a thread
Yeah,
sleep. Yeah.
yeah,
So yeah, you're no longer in task world. You're inside of a thread. You're synchronous, and so yeah, thread sleep.
yeah, yeah, yeah. Because if you
Mm-hmm.
look at it, so this yeah, this is the top level. So here is where we enter.
Mm-hmm.
Yeah, with transaction async. This one will just make a new lambda with that callback inside,
Mm-hmm.
and it will put a task around it,
Mm-hmm.
around this func of t. Um, and actually, that callback goes into with transaction. That's this one. With transaction, we'll call with connection.
Mm-hmm.
So it makes a new function which goes into with connection.
Mm-hmm.
And with connection, we'll make another function.
It's the
It
decorator pattern.
creates it creates a connection here.
Mm-hmm.
It gives it to the callback. It executes it, and if backoff is enabled, it will go to the next one, the
Mm-hmm.
next level, and otherwise it just returns that function.
Yeah.
So if backup is enabled, then we get here, which will return the callback. And if it fails, it will sleep and it will retry. It
Mm-hmm.
will do another attempt. It stays into the while loop.
Yeah, that all looks right. So the thing that we're trying to figure out right now is why does the C version of this test give a different result where it doesn't look like um, it's it's locking and it's not failing on the second read.
Yeah. Um,
Hmm. So it could be that we're putting SQLite in a different state at the beginning of the test.
yeah, different
Um,
configuration.
yeah, because everything you said about the write ahead logging. Um,
Mhm.
yeah, if for some reason that wasn't taking effect in this test, um, then it might not be um,
Yeah.
as open with the
Now,
reads.
the moment that you start the connection factory, I do
Mm-hmm.
enable this wall mode, and I do have a test.
Mm-hmm.
I probably, yeah, why is this one not? No, it doesn't want. Never mind. Just, oh yeah, these are all because I added that parameter, that ID parameter. So oh no, it's not that one. You have to. So if I run this one, that one is passing. Now, what is this test doing? We are again creating a new database, and then he will just send a comment to put that database, which should be in wall mode normally,
Mm-hmm.
because when you create a database, he puts it automatically in wall mode. He puts it in a different mode, which is in the journaling mode. And he returns that mode. So
Mm-hmm.
that mode should be delete, and that seems to work. Afterwards, I put it back into wall mode, and also that seems to work.
Okay. Can you add a test that doesn't do the pragma, but it just returns the current mode?
Yes, that should be possible. Let me see. SQLite. See, in the SQLite homepage, how do we do that? Documentation. Programming interfaces. And here, the complete documentation. Where was that? Open Walmart.
Yeah, I think it's just Pragma journal mode without the equals, if I'm reading this correctly.
If you just say Pragma journal mode.
Yeah.
Right, let's see. Journal. No, I'm doing something wrong here. Why is it beeping? Let's try. He will tell us what it does.
Yeah.
Run.
Okay, so yeah, now you've got it asserting that it's delete. Okay, but you're just doing this so you can see the output.
Wait, which one is it?
Yeah, I think you have to expand the
But
the
for
one with the X.
for one or the other reason, I cannot expand it.
I mean the red X just below the selected line. If you hit the arrow to expand that, there's a test inside of that.
Okay,
Yeah.
it's
Now
that
you can
one.
select that one, and it said expected delete. And what did it actually get? It
Now we can. Mode expect to be delete,
and
but
it got wall.
wall.
Yep. Okay,
Yeah,
so it is
good.
initializing it to wall mode. Yeah.
Yeah.
Okay.
So normally that should be correct.
Mm-hmm.
If it would be otherwise, we would not be able to read and write at the same time.
Yeah.
And the other test here, write while reading, that one is working.
Mm-hmm.
So that one is reading and writing at the same time. Oh, I didn't run that one.
Yeah. Yeah.
Now,
So at this point,
what?
I can see two options. One, continue trying to figure out what's the difference between this and the C test, and to do that, I think it would have to be somehow capture the exact commands that you're giving to SQLite in each case. If there is a logging interceptor you can install to just spit out all the commands, then you should be able to compare them side by side.
Compare. Yeah. Now there are a few diagnostic possibilities: tracing and error logging.
Mm-hmm.
And I think that's what I need to investigate now, because otherwise we are not gonna.
Mm-hmm.
Because I might. So we are still using that base library,
Mm-hmm.
but also that base library might still enable some modes which are not enabled in the C# version.
Yeah.
So indeed, having all the comments that go to SQLite might be a good solution.
Yep. And then the other path that I see, which probably not the one that you are interested in taking. Is
It's forget about it.
yeah,
No.
except that that the retry fixes it, and we need to have the retry anyway. Um,
Yeah, but something that works without knowing makes me nervous. If I like to tell my customers it works
mhm.
or it doesn't work, but it works and I don't know why. Uh, that's as bad as it doesn't work and I don't know why.
Mhm.
Um, no, if in the end it's logic, it's math, it's programming.
Yeah, this is
So there
knowable.
is no reason. Yeah, there is no reason why we will
Hmm.
not find it. Um, but I was thinking perhaps something in that async code that I was doing wrong or did not well understand. But
Not from what I see, no.
yeah,
Because nothing that code is doing should have caused the database being locked. Um, yeah, I guess another
well, yeah,
line of investigation would be to take a look at the SQLite source code and look for that error message, and uh, and see if there's some information you can infer about why
why?
that lock could be
Yeah,
happening.
yeah. That might also give us some hints. Good.
Yep.
Now I will dig deeper into the tracing um, to see whether we can find something there, and look into the source code of SQLite, and let's have a look whether what this error message is
Hmm.
wants us to tell exactly. Good, but that means for the moment still stuck.
Well,
Yeah.
um, but but we do have some progress on the Jinaga.JS side.
Okay.
So
Nice.
so yeah, the first thing is the error that we saw. Ah, have a good day, love.
Yeah, I'm back.
Okay, that was less than 45
No,
minutes.
no, this was not Discord. It was me
Oh,
who pushed the wrong button. I wanted to stop the sharing, but
got
yeah,
it. Yeah. So yeah, last time we were going through the integration tests, and we changed it so that rather than before everything setting up the Janaga instance, it did that before each, um, and then it it failed. The
yeah.
um, the problem was that it was always failing, and that failure was hidden because I was not awaiting a promise. And so yeah, by changing um, the order of things, then uh, it shook that loose. So so yeah, I figured I fixed added the await, and and then the reason for the failure was just that I was expecting login to return the user fact, but instead login returns a an object that contains the user fact and their profile from the identity provider. So so yeah, just had the test incorrectly written. So that's the sort of thing that I usually catch by writing a failing test first, but for some reason I guess I didn't write a failing test in that case. Or maybe I thought that I
Okay.
had.
Yeah. Okay. So you write a failing test. So if the test stop for one or the other reason, the failing test will not
Yeah.
give you yeah.
Yeah. So if I forgot to await a promise and I'm expecting this test to fail, then you would see it pass because it got through everything and then cleaned up before the promise completed. Um, and and then that should have caused me to investigate that, find the await, see the failure, and then fix it. but apparently in that case I didn't follow that pattern.
Happens.
Yep. But then after that point, we had some progress. So, all right, this is the Improving You course library. Let's go back to Jinaga. All right. So now I've got all of the integration tests passing. And if we go back to Jinaga test, it is still doing the before each. So I've got this now separated as two different suites of tests. So this one is the kind of test that we saw before, where before each it's setting up the Jinaga server instance and then closing it, and it's doing all the tests with the J instance that that Jinaga server gives you back. And so this is how your server-side application would be working as the device itself. So Jinaga as a device. So that means within the context of J, there's no user that's logged in, but there is a device. So we can say j.local, and that gives me back a Jinaga device.
Yep.
And so that is very useful for configuring per device information so that it can participate in a larger multi-tenant space. But okay, when you go to this server, it's got some facts that are associated with this particular device. In particular, as a user of the Improving You application, for example, when you hit the URL to just take a look at the Improving You courses, that device fact that server knows about has a successor that says that this device is serving up this particular company, and it's a multi-tenant system, so we've got the ability for multiple company facts, but on this device, this is the one. So when you just list the courses, it's going to start at that company. And then in order to... Mm-hmm.
So in fact, the identity becomes the device and not the user who logged in.
Right, exactly.
Yeah.
And so in order to get started, when you start up the Improving Your application, you initially log in as whatever user. It's the creator of the of the company object logging in, and then you prove to it that that you are the administrator, and then it sets a successor to that device that says, okay, the company that you've created, that's the one that we're going to serve.
Yeah.
So this is this is doing that. That it's simulating that behavior. So we we do our j.local, we get our device fact, and then we issue another fact for configuration, and then this check right here is deliberately going to create a different Jinaga instance, and we'll take a look at how it does that in a second. And then it logs in, or it gets the device that is going to be equal to the same one, verifies that, and then it runs the configuration from device, gets back configurations, and that should be an array containing just this particular configuration here, that particular fact. So the way that that check does its thing is it does a brand new Jinaga server create, closes that, and does the callback with that particular J instance. So it's as if we had shut down and restarted the server connected to the same database. That's the key, is that we're checking not the memory inside of that thing, but or really that thing. IntelliSense. But instead, we're checking the memory in the database, the storage in the database. So that is Jinaga as a device, and the tests that we've seen before are still running inside of Jinaga as device, but now there is Jinaga as a user.
Yeah.
So this before each is a little bit more complicated. So Jinaga server create gives you back not just the J, which now we're calling J device to make it distinct, but it's also returning a with session. So that's a function that will allow you to run a Lambda as a user. So you give it the request object, and so here we're kind of mocking out the request object. So it just has a user with the an identity provider, the ID that identity provider gives you, and the profile from that identity provider.
Michael,
Mm-hmm.
but I don't really understand the device, the Jinaga connection to the device is in fact the configuration that you store on the device.
Mm-hmm.
What is exactly the difference? Because if I remember well from long ago, the purpose was to have local configuration information, which is
Yes.
not on the server. So
Okay.
does that mean?
Yeah, it's so the device could be the local device. In this case, the device is the server device. Yeah, so it's the it is the same idea. It's just that the term device really means the node that you're on. So whether that be a client or a server or some distributor out there in the middle.
Yeah, but so with that first connection, there you have a Jinaga database which is only on the device, or which is synchronized to a server.
It stays on whichever device Jinaga is running on. So so what you're thinking about is Jinaga running on the client. So if you do j.local within client code, you're going to get a device fact that stays on that client.
It's never synchronized to a server.
Correct.
To a distributor.
Yes, that is correct.
Okay.
And so this is code that runs on the server. So when the server says j.local, then it's going to get the device that is only stored on that server and is never synchronized to any other servers or any devices or any client devices, right?
Yeah. And then why do we have to change connection? The check routine just now was making a new Jinaga connection.
Yes, and there it is. And that was because the tests that I started writing were passing. In fact, even some of the tests that we saw before were passing when they should have failed. So, for example, this one right here. So we did a, let's see. Well, Yeah, that one I didn't. Yeah, let's go ahead and go with this one. Um, yeah, because that one I think I should have put check around um, the assertion, but I didn't. But yeah, in this case, if we didn't use check and just took this same j from up here, then we would
Yeah.
already have in memory inside of this j instance in its local cache, we would have the device object and the configuration object, and so this query wouldn't even hit the database,
Okay.
or rather, um, yeah, would it? Yeah, it still would hit the database, but it would already have some of the information. The thing that was failing here, or that was succeeding when it should have failed, is that it wasn't getting the fact type ID of root when it ran this query. So
Yeah.
it looked um, at the steps within the query, and it pulled out all the facts that were named inside of those steps, but the starting type was not listed within those steps, and so it was generating a SQL query where it was trying to um, put to the fact type ID of the root in the where clause, and if it was um, in memory, then it had that fact type ID. But here, that memory is in a different object, and so we've loaded a new object. It doesn't know the fact type ID of root, and this was putting undefined inside of the query parameters.
Okay. But so that the j.device or j.local, when will that be used on a server?
Yes, that would be used like this is how it's used inside of Improving You. Um, so I need to get the company fact, um, and so on the server I grab j.local, and then I query the configuration from device, and if I find exactly one, then that's the company. Otherwise, I return null. And so configuration from device is saying match the configuration, where that's the device. Nice simple simple little query. Actually, it should have another such that, because this should actually be the mutable property pattern. I haven't run into that because I haven't had to reconfigure a server yet, but I'm about to. Actually, no, I'm not about to have to do that. So I'm still kind of safe. But yeah, that should be the mutable property pattern. That way,
But
yeah.
you say, okay, that's about one company, but the
Mm-hmm.
distributor will have data from a lot of companies.
Yes, yes, and so if you put that server on the substrate, and it learns about all these different companies, we know that whenever you type in a particular URL, it's going to bring up the courses for a particular company. If we wanted the application to behave in more of a multi-tenant way, then the application would have to present to the user, hey, which company are you a member of? Or maybe that would be from a claim inside of their from their directory. So there are different ways that you could get to the company that you should serve the information about. In fact, I like the claim idea. That makes a lot of sense. And you could go to the same server, log in from an identity from a different directory, and then it says, oh, you're a member of this company. I'll show you these courses. In fact, that's the way that we want to do the offices. Right now, you have to select from a drop-down list which office you want to see the courses for. But
Yeah.
that should be a claim inside of um, Active Directory. It was just for the longest time we didn't put that in Active Directory. We have that now, and I just haven't taken advantage of it inside of here. But yeah, so then you log in. It'll know which office you're a member of, but yeah, the company itself. If we take a look at what this company fact looks like, it's a particular name. So that name is, excuse me, always going to be improving in this particular application. But from user. So if you log in as a different user, then
It's a different company.
Yeah.
Okay.
So somehow the website needs to know my public key.
Yeah.
And the website needs to understand. It needs to trust that that I was the person that set up the company in the first place. And so when I log in, that creates the user fact with my public key. But then I didn't want it to be just the first person to log in. It has to be a deliberate action that somebody says, I've logged in and I want to create a company, and I want that to be the company that everybody sees when they log in. And that's where the configuration thing comes in. So if I find the references here, yeah, here is where we do the /configure. So so if you post to /configure, then what you're doing is you're posting a secret. So that's in the body, and if that matches some expected secret, then it says, okay, I believe that you are the administrator. And then this is where it does the with session thing that we were just talking about inside the tests. So now I'm going to get a Jinaga instance that knows not only j.local, but also j.login. So it knows the device and it knows the user. Mm-hmm. And so this is going to create a new company called Improving, created by that particular user, and then set up the configuration for the device.
Yeah.
So now when you query that device for its successor configurations, you'll find this one. It'll point to that company, and you'll be able to list the courses.
Yeah. And the next time you use that device, you will automatically get to the right courses.
Yes.
Okay.
Yep. So kind of finishing off the story there, the expected secret is either a randomly generated 6-character string that is just output to the console, or if you've set the configuration secret variable, environment variable, then it's going to be that. So if you're just running it locally, then you just take a look at the console the very first time you run it, and when you log in, it redirects you to a page where you can just paste that variable in and it'll do this post. But then when I deployed it to the server, I set the configuration secret environment variable inside of the Azure portal. And then I didn't even have to look at the console. I could just type that secret in. And it said, okay, there you go. So that was a one-time thing.
But that means that everybody who has that secret can change the
that is true.
Attribution between device and company.
Yes, that is true. So that's why the secret is either visible on the back end because it was generated there, or set on the back end because you set the environment variable. So it's the same level of permission that an administrator would normally have. And so now that I think about that, that's probably why I went with the not having a such that here. So if somebody does change the configuration, then now we've got two facts, and it won't trust either one of them. So it'll break in such a way that we'll be able to detect it, and we'll be able to fix it. And the way that we would fix it would actually be to push a change to the code to ignore the other fact, which would actually open up the ability for somebody to switch it to theirs and take it away from you, because they could then post the other fact. But yeah, the chain of trust has to start somewhere, and this is basically where it starts.
Yeah, you cannot delete immutable facts.
Yep. Yep. So with that, I was able to so that's Jinaga as a device. Jinaga as a user. So we've got our with session, which we saw over here, was we pass in the request and a callback function that gets our new Jinaga instance. So so here the request, we happen to know that the only thing it's going to look for in that request is the user, and it's going to expect to see these properties. So pretend to be logged in with the user with that ID, and then that is excuse me, going to if it doesn't yet exist, put that user into the key store and give us back a Jinaga instance that when we log in will give us that particular user fact. So what this is doing here is it's saying, all right, this is the setup. I'm going to, before each, do this setup, and I'm going to await this promise within the with session. And this J that you have here, which is that J right there, that is the Jinaga instance for that particular user. And this promise here is going to resolve whenever you call this done function. So then right here we can call done. We can await the session, so we know the session has completed, and then we close the Jinaga server instance. So basically turned this inside out, and the test effectively runs inside of this this with session callback here. So now that allows me to do a whole bunch of stuff with j.login. And that was the basically the final part of Jinaga.JS that or the optimized database that I needed to get finished up. So the big the main takeaway here is that Jinaga.JS is completely working with the optimized database, and we have a much better set of integration tests to verify that.
Okay. So with the optimized database, you will say with the new structure with the indexes?
Yes.
And with the tables, yeah.
Yep. Yeah, and the excuse me, the ancestor table, as opposed to the recursive query. There was one really big breaking change that I had to do in order to make this all work. And that is, if we take a look at, well, in fact, we can see it in in here. So right here, this is a specification function that is looking for the user fact given a particular name. A little bit harder to read because this is all in raw JavaScript, no TypeScript. But so we've got our ensure name has. It used to be that you just specified the field. So name has a field called from, and that's your predecessor. But in order to make sure that every role was declared by a particular type, which is a decision that we made when designing the database, you have to specify the type right here when you ensure that that the fact has a role. So so we say, okay, starting at name, it has this field called from, and that points to something of type Jinaga.user. And now I can just match that particular user, and that's what this specification function does. And we use that in order to authorize the username fact. Only the user themselves can assert their name.
Now the new code with the indexes, have you tested it meanwhile on improving or not yet?
I have. So going through this iteratively as I made more and more things work, I would then pop over here and run it against improving, and see if it could work end to end. So now we have our so this is still looking at the fall 2021 semester. Spring 2022 has begun. But so you can see here, enter the following secret during configuration. So I will copy that. And then when I try to log in, this is the fake login screen that if you don't have an identity provider set up, then it'll say, okay, I've got these test users. So I'm going to log in as the improving you director.
Yeah.
And then it says, okay, I don't have a configuration. So here's the configuration screen. You see this for the only for the first time. Paste in that secret, and we hit configure. Boom. So this is a defect in the improving you application, but it's actually proving that Jinaga.JS is doing the right thing. So it rejected this part right here is a one remaining defect in Jinaga.js. So that's the last mile right there. So it rejected Jinaga device, and that was right here when I was trying to, with session, do a j.local. So I'm logged in as a particular user, and I'm trying to get my local device. In this particular database, this is a brand new, fresh, not initialized database. It doesn't yet have a device fact, and so it's trying to allocate one for the first time. And it can't do that because it's logged in as a user, and the user is not authorized to create the device. So I need to make this basically make device a self-signed fact, just like user is now. So when you do a j.login, if the user is not yet in the key store, then it creates a user fact, and it signs it with that user's private key. So it's now a self-signed public key. So yeah, same thing has to happen with the device. And that will get us past this one, where the device is not allowed to, or the user is not allowed to create the device. because once I do that, then the device will already exist and it won't be rejected. But then this one right here, this is an improving you defect, because I don't have the authorization rules set up for improving you configuration.
Okay. But you didn't yet copied all the facts to the new database structure to check performance.
No, I have not yet done that.
Okay. Because that would be interesting to see what is the difference in performance.
Mm-hmm.
Because it should be way faster now with indexes.
Yep, I believe so. So that's pretty exciting stuff. All right.
So I think we have both things to work on.
Yes. Yes, we do.
Mm.
Yeah, very, very close. Very close.
Mm. Good. Then I'm gonna try to get SQLite finally up and running. That would be nice if that could be done this week.
Sounds good.
Okay. Michael, yeah, next week.
Next week, yes, indeed. I'll be here.
Have a nice working day then.
Indeed. Yeah.
You're still training the people today.
Yeah, they are. They're mostly taking care of themselves now. I was really happy to see that some people were asking some questions, and I paused for a little bit. Yep, other people jumped in, started answering. It's like, okay, this is running itself. This is good. So yeah, I'm spending less and less time on this cohort. They're doing a great job.
Then you have time for new things.
Yep. Indeed.
Time for Jinaga.
Yeah. If only.
Yeah. Okay, Michael, thank you very much.
Thank you, Gun.
And see you next week then.
Indeed. See you then.
Okay, bye-bye.